Good day, students. In this video, we are going to talk about surface area. And I will not lie to you, surface area is not a very complicated skill. However, there are quite a lot of steps. We kind of have to break down every problem into like a series of mini problems. So I'm going to do two examples in this video. So just kind of right off the gate, if you want to, you can write down this definition of surface area and then just split the rest of your page into two columns. When I work in each column, I'm going to kind of fold my paper like back so it doesn't like distract you from the problem I'm working on. So go ahead and take a moment to pause. You don't have to copy down kind of all the examples and stuff yet, but like the definition and then example 1 and example 2, and then draw a line to kind of make a column on your paper. Okay, so the definition of surface area is when we're finding the area of a surface of a three-dimensional shape. So for example, like we have two examples here that we're going to work through. And we use surface area when we do something such as like if these were some sort of box that we had a Christmas present in, or some sort of like birthday gift or some sort of present that we wanted to give somebody. If we wanted to find the exact amount of wrapping paper that would cover this particular three-dimensional shape, that's called the surface area. Construction workers use surface area when they are trying to figure out, how much brick do they need to put on the outside of a building. They have to find the surface of, all of the walls of the building, for example. If people who needed to like put on shingles on a roof, they would need to figure out what is the surface area of the roof. There's just all these different things that we would need. So instead of volume, which is talking about like how much a three-dimensional shape can hold on the inside of it, surface area is talking about the area that the outside of the three-dimensional shape is taken. And we're going to find the area of a surface area of a shape very similarly to when we did the composite area of shapes, where we just added up all of the different shapes that made up the particular composite figure we were looking at. However, in surface area, we kind of have to think about what our three-dimensional shape would look like flat, or we have to consider like all the different sides. So the first example we're going to do is we're going to do a triangular prism. So I'm going to go ahead and fold back the second example. So that way we're only focused on the first example. So you can go ahead and pause and go ahead and copy down what the shape looks like. Okay, so when we find the surface area, we are essentially going to figure out what is the surface of the front, our sides, the back, and the floor or the bottom. Like we're trying to find the area of the entire three-dimensional shape. We can draw what's called a net, which is basically if we were to like cut open this three-dimensional shape and lay it down completely flat, what it would look like. It would look like one of our composite figures. For the sake of time, I'm not going to do that. We're just going to think about each shape in terms of kind of three different areas. So what do the front and back shapes look like? What does the top and bottom of the shape look like? Like what I like to call the floor and ceiling. And then what do like the sides look like, the left and the right side? Because a lot of times what happens is these shapes are proportional. So like what the top and bottom shapes are in terms of area are going to be the same thing. So it makes our job a little bit easier. So in this triangular prism, the first thing we're going to do is we're going to figure out what is the area of the front of this shape. And we also know that like the front of this shape is a triangle. The back of this shape, if I was to continue drawing it, would also be a triangle with all of the same dimensions. It wouldn't be a prism if the back dimensions were not the same as the front dimensions. So to find the area of this front and back, I'm just going to kind of draw what it would look like. Okay, so we have our triangle. This is what the front and back looks like. Our height is going to be 6, and then our base is just going to be 4. Those measurements of 7, we don't need to find the area of this triangle. So I'm just going to plug into my formula 1/2 my base of 4 times my height of 6. And that's going to be equivalent to 1/2 of 4 times 6, which is 24. 1/2 of 24 is 12. So the area of one of these triangles is 12. But the total area for the front and back is going to be 2 times 12, because if the front triangle has an area of 12, then that means the back triangle, which I did not draw, but you can imagine that it's there, would also have the area of 12. So in total for the front and back, our area is going to be 24. And in this case, it's centimeters. I'm just going to leave the centimeters off until the very end. So in terms of finding the surface area of this triangular prism, we have officially found the total area for the front and the back shapes. And now we're going to look at the three sides, the three rectangular sides, and find the area for those. So as you can see, this, we would call this is probably like the way that we're looking at it here. This is like the right side of the shape. So this is going to form a rectangle that has a width of 7 and then a length of 12. And you could see based on the other side that this one is also going to have a width of 7, and then that length is going to be the same amount of 12. So we have two rectangles that are 7 by 12. So that means our left and right side are going to be the same dimensions. Now, sometimes in a triangle, right, like these two sides do not have to be the same measurement. So you have to be careful. Like this back triangle, like if this was like an 8 or something, that means this triangle on this other side that we can't see, excuse me, not triangle, this rectangle on the other side that we can't see would be a 7 by 12 rectangle. But because they both have a measurement of 7, then that means that both the sides make up a 7 by 12 rectangle. So our left and right sides, if we were to kind of draw them, are to look like this. They're a 7 by 12 rectangle, both of them. And so to find the area of these two rectangles, I'm just going to find the area. So do my length times width. So 12 times 7, which is 84. But then we have two of these rectangles, right? This is like our right side. We also have our left side. So the other side is also going to be 84. So the total area for the left and the right side combined is just 2 times 84, which is going to be 168. So we have now found the area of our left side and our right side, the side we can't see, as well as the front and the back of this triangular prism. So that's kind of what we calculated so far. And the last piece of the three-dimensional shape we need to calculate is what I like to call the floor. So the floor is going to be kind of this bottom part. If you think about this as like a camping tent or something, it's going to be like the floor, the bottom part, the part that's like resting on some sort of surface. We're going to find the surface area of that. So the floor, is going to look like this. It's also going to be a rectangle. However, in this case, the length is still going to be 12 because that's the length or the length of the prism or the height of the prism. But that base of that triangle was 4. Let me go back up so y'all can see. So you see how like this is going to make a 4 by 12 rectangle here on the bottom. So if I was to find the area of that, I have no ceiling, right? Like there's no, if this isn't a rectangular prism, because it comes to just a point up at the top. So I'm not going to end up doubling this amount. So our floor is going to be 12 by 4 or 12 times 4, which is 48. So all of these areas that I have just found, and like I told you, the math itself isn't too hard, right? We're basically finding the areas of rectangles and triangles, but we're trying to consider all of the different shapes that make up this triangular prism. And now we have officially found the front and the back triangle areas, our left and right side. You could kind of think about them as like the walls of this tent that is created here. And we have found the area of the floor. So these three areas are what we need to find what's called the surface area. Okay. And within surface area, there's also something called the lateral area. So the lateral area is when I find the area of pretty much everything in the shape except the base shape. So our base shape in a triangular prism is the triangle. So the lateral area is just going to be the amount for my left and right side and the floor. So if I wanted to find the lateral area of a triangular prism, the one that we just did, I would add up the left and right side and the floor areas, which is 168 and 48. And this makes 216 centimeters squared because we're talking about area. Now, the reason why we might need lateral area is, let's say, for example, a brick worker is trying to figure out how many bricks are needed for the walls of the outside of a house. They don't need to lay bricks. Excuse me. They don't need to lay bricks on the ground or on the ceiling, right? They just need the walls. So they would just need to find the lateral surface area of the house, as opposed to the total surface area that includes like the floor and the ceiling. The total surface area is just going to be this lateral area plus the amount of the bases, or pretty much all of the areas that we have found for the front, the back, the left, the right, and the floor. So that's going to be 216 plus that original 24. That says plus 24, which is going to make 240 centimeters squared, because we are talking about area. So when we find the total surface area, we are essentially looking at a three-dimensional figure, and we are trying to figure out how much area do all of the surfaces make if we were to combine the areas of like the left, the right side, the top, the bottom, the floor, the ceiling, the front, the back, whatever the kind of shape is. So this was an example of a triangular prism. And now we're going to look at an example of a rectangular prism, or if it was a cube, it's both going to be the same format.